mode.
All right, let's get started. Elizabeth Eyre, Portfolio Manager here at Redgate Software, and it's our pleasure to welcome you all to our DevOps 101 webinar. We have with us James Betley of DevOps Guys to give us a one-hour introduction to DevOps. James is the head of education at the UK-based DevOps consultancy, the DevOps Guys. He spends his time helping a wide range of organizations optimize the way they collaborate to deliver better software faster, and he also runs their successful DevOps training programs. So today is a very condensed version of their full-day DevOps Foundation course, so James has accepted the challenge of condensing it to 1 hour. Hello, James, and thank you very much for joining us today.
Thanks, Elizabeth. Yeah, it's a pleasure. Yeah, I'm going to have to talk really quickly, and you might have to hurry me on a few slides if I'm dwelling on a point a little bit too long. But yeah, let's see how this goes. So I'll just crush straight on then. So welcome to this introduction to DevOps. As I say, it won't be too detailed. But we'll try and cover as much detail as we possibly can within this 1 hour. I'll probably chat for about 40-45 minutes. If you've got any questions, then fire them over, and then we'll leave some time at the end to answer some of those questions. So we'll start off with my favourite subject, that's me. We'll go on, what have I done? I'm from a dev and ops background. I've worked in that sort of no man's land between dev and ops for many years. So this whole DevOps movement has been kind of tailor-made for me, I suppose. I was a continuous delivery consultant for some time as well. So that's a very nice fit into this DevOps world. I'm now with DevOps Guys, and I, as I mentioned earlier on, head up the education part of our business, and I'm also a consultant and a coach. Here's what we're going to be covering today. So we'll look at a bit of a background, a history, a 101, and we'll start to define DevOps, because someone once said to me, if you ask a room of 10 people to define DevOps, you'll get 11 different answers, and that is exceptionally true. There's no set definition of DevOps, so we'll try and cover that off nice and early. Then we'll take a look at why DevOps happens. So that ties in quite nicely with the history. And then we'll cover the two main sections, the DevOps principles and practices, before going on to how we do DevOps, or how organizations do DevOps. And then finally, we'll take a brief look at some of the DevOps KPIs. This is the history lesson. It's not that old, so it's about 8-9 years old now, DevOps. I suppose you could say it kind of started around 2007, 2008, but a chap by the name of Patrick Dubois was working over in Belgium, and he was, I believe he was watching a webinar, in fact, about, I think it was velocity in 2009, and he thought, how do I set one of these up and talk about dev and ops and collaboration between the two groups. And John Allspaw, who was giving a particular talk at Velocity, talking about their deployments at Flickr, said to him, set up a conference, go and do it. So he started something called DevOps Days in 2009. I think the first one was in Ghent in Belgium. And really, it was a conference just that, really around bringing dev and ops together. And obviously, that included quite a lot of good practice and automation, stuff like that. And it was there that the sort of term got coined, DevOps. So DevOps Days just got shortened to DevOps, and so the movement began, really. Now, this is the tricky slide. I could bang on about this for hours. What does DevOps mean? So defining DevOps is notoriously hard. You'll get a different definition from the different types of people you ask. For example, vendors will tell you largely that it's about automation. If they're trying to sell an automation solution, recruiters will tell you that it's about anyone who can badge themselves as DevOps. So on the far end of the scale, you've got sysadmins who code, who used to be called sysadmins, and now they're rebadged as DevOps people. We've got DevOps engineers who are the sort of specialists in the automation area, I suppose. So we see quite a lot of that. We work with a lot of DevOps engineers as well. There's quite a lot of talk about that being a bit of an anti-pattern, DevOps engineering, but we don't think so. And then there's the other far end of the spectrum, which is all about value delivery from business to operations. So when we talk about DevOps, we don't think of the two teams, development and operations. We see the development side of businesses and the operational side of businesses. So when we look at DevOps, we think the business and operations. So we've got a rather broad view of what DevOps is. We see it as optimizing value delivery across your whole end-to-end. And that includes your processes, your people, your tooling, your processes. Yeah, I was thinking about that. But anyway, it's a lot broader than the sysadmins who code who are at the other end of the scale. Generally speaking, I think the most popular definition of what DevOps is somewhere in the middle there. Amazon have a very good definition of it, which just brings together people, processes, and tools. So that's quite a popular one as well. One thing to really sort of stress here is that when we talk about DevOps, it's not just about automation, and we'll go on to see that in a little while. Well, actually, we'll talk about it here, to be honest. The DevOps CAMS model is something that's been around for quite some time. We were talking about this a few years ago. It used to be CAMS, C-A-M-S, until Lean popped its head in there because we all realized that actually we forgot about Lean IT. Jez Humble produced a book called The Lean Enterprise, which reminded us that Lean is really quite important to this. So it became CAMS. The key thing to I suppose underline here, we won't dwell on all of the different parts just yet. We'll go and have a look at those a little later. But the key bit I want to pull out here is the automation one again, and just to really stress that it's just one part. So culture, lean, measurement, and sharing are as prominent in DevOps as automation is. Here's another way of looking at it. Continuous delivery plus operability equals DevOps. You might be wondering what operability means in this case here. We'll move on to that in the next slide. But continuous delivery, not just having a continuous delivery server or Jenkins or TeamCity and Octopus or something like that. We actually mean the behavior, the practice of continuous delivery, plus the mindset of thinking about operability. That's what we sort of define as DevOps. And as I say, this is what we talk about when we say operability. We mean a lot of words that end in -ity, such as maintainability, scalability, deployability. That's a really good one. Google, for example, have that deployability as a feature. So if you are writing an application, a new piece of code, or a bug fix even, and it doesn't have a way of being deployed, it's not deployable, it doesn't fit into the deployment system, then down your tools and sort that out as if it was a severity 1 outage. You know, that is the most important thing. If it's not deployable, stop doing it. So deployability is a first-class citizen. Monitoring, alerting, also people tend to sometimes put security in here, but we see it as possibly something slightly different, and we see that security really is a feed-in rather than an operability. Yeah, some people say security as well. And we also hear the term DevSecOps, which means Dev, Security and Operations, just to remind us that it's equally important. Now we'll go on to why DevOps happened. So I've got a little graphic here which some people might look at and think, yeah, I recognize that. That's where I work, or that's where I used to work. You had the Department for Change, that's the Dev team, and you had the Department Against Change. The Department Against Change, we'll have to have a look at how that happened. But the Department Against Change were, for example, the operations team, who were very focused on stability. And then the Department for Change, obviously development, who really wants to get those new ideas out, satisfy the business for their quest for even more features all of the time, and basically respond to customer demand, as well as just play with cool new tools. Obviously, that's great. That's what they were being bonused on. That's what they were focused on, and then you've got the operations team who are equally, they had SLAs to worry about. They were also being bonused on uptime and things like that. So this was really what we were stressing about, what we were kind of fighting with. How do we keep up with the demand for new features and new technologies? So on the one side, we felt under pressure to keep up with demand for new features, new technologies, customer demand. We were really under the cosh, and we really had to work very, very fast to get stuff out the door. And then on the other side of the fence, we needed to maintain stability and high performance. So that's what was really concerning us. We weren't that focused on demand and demand for new features, new technologies especially. We just saw them as risk. So when we were trying to answer how do we keep up with the demand for new features and new technologies while maintaining stability and high performance, we were actually splitting that into two separate questions. We had the one side, which was dev, and they followed their desires to keep up with new features and technologies, and the other side was ops, and they were focused on stability. So we created two silos and two competing mentalities, really. Of course, answering that question was always going to be impossible because they're at odds with each other, really. Unfortunately, we carried on asking ourselves, and we were forever seeking answers to that particular question. The problem was it was the wrong question. We should have been asking ourselves, how do we deliver maximum value to our customers and shareholders? That's the kind of goal and objective that would have brought both dev and ops together. So we really have to understand what our overarching ambition is. What's our goal? What's our objective between both dev and ops, both the business and the operational side? If we work towards that, then we'll work collaboratively. And this is really where DevOps came from. That realization that there is something that actually pulls both sides of the spectrum together. So that's really the first ingredient, and it's called the shared goal, and that's what unites us. That's what unites dev and ops. So we no longer have this these silos and these competing objectives of trying to maintain stability and trying to create fast change. So now we'll go on and have a look at the principles behind DevOps, and we'll revisit this, the CALMS model. We'll take a look at each one: culture, automation, lean measurement, and sharing, in a little bit of detail. Not too much though, and we'll try and skip on to the practical application of DevOps in a little while. So in the DevOps CALMS model, we see culture, as you can see in the picture there, as kind of the underpinning part. And what we talk about when we say culture is around that shared goal, is having a culture of collaboration, having a culture where people empathize with the different groups, having a culture where we're pulling people together and involving people at the right time rather than involving people as an afterthought. That's particularly true around operability. So operability, we used to call these non-functional requirements, didn't we? Which is a terrible term because it's very negative, non-functional, and it's also wrong because they are functional. Deployability is very much functional. So it's about thinking of those things as first-class citizens up front. So there's a whole culture change of stopping thinking of these NFRs, non-functional requirements, as these afterthoughts. Shared goals, as we just mentioned, collaboration, including people rather than excluding people, and not really just focusing on your own concerns, not focusing on your own problems and your own team. So developers focusing on optimizing how they develop, QA teams focusing on how they optimize how they work, and operations people focusing on optimizing their ops part. That's not what the culture needs to be. The culture needs to be looking at the end-to-end. We'll take a look at that in Gene Kim's 3 ways of DevOps in a moment. Now we'll take a look at the automation. So automation, the key to the automation part, it's an enabler for DevOps. It's not DevOps in itself. Automation really helps us achieve DevOps by enabling these fast feedback loops. without fast feedback, without being able to press a button and get our code out into production or get our code out onto a test server or something like that, without being able to spin up an environment at the press of a button, we have to wait ages and ages and ages. And we don't get that fast feedback, which means we don't get direction, which means we move on to doing other stuff that we're concerned with. If you're a developer, you'll just go back to writing some code. You can't be bothered waiting half an hour or 2 days or 3 days to provision a server or something like that. Why should you? So it just focuses you back on doing your own little siloed work. So fast feedback, the ability to get stuff deployed, stood up, working in production is absolutely essential. It helps us to create that culture of collaboration, for example. And yeah, as we say there on the slide, we need information to guide our decisions, so that automation really is key. Lean IT plays a big part, as I said, and especially in the way it talks about systems thinking. It talks about thinking of the whole system, the end-to-end, and not just focusing on your own individual part. There's a great book by a chap called Eli Goldratt called The Goal, and it's kind of like the precursor to the Phoenix Project by Gene Kim et al. It's written in novel format, and it talks about essentially a manufacturing industry and how they overcame their problems, and how the lean approach has helped there. And it focuses on this sort of end-to-end appreciation of your system and optimizing the whole system rather than individual parts of the system. And Eli Goldratt comes up with this term called the theory of constraints. And I'm going to paraphrase here a little, but he basically says in any system there is a constraint. And if you spend your time optimizing anything apart from the constraints, you're essentially wasting your time because you're not going to make a difference until you start to optimize the constraint itself. Of course, the reality is if you optimize the constraint, you're inevitably going to reveal another constraint. The right thing to do there is then go and try and optimize that. So rather than us focusing on optimizing simply the dev side or the build side, let's focus in on builds. We used to spend an inordinate amount of time trying to get builds down to within less than 5 minutes back in the day. And while we were focusing so heavily on trying to optimize our build times, we were still waiting 2-3 weeks to get a server provisioned. So it was we thought we were doing some valuable work, but in reality it wasn't quite as valuable as if we'd focused our attentions on what was actually the constraint in the system there, and in this case it was the lead time for provisioning servers. So the theory of constraints teaches us to focus on what our actual constraint is, and this is a big part of DevOps. This is what Lean brings to it. So localized optimizations are a mirage, and as I said there, being busy doesn't equal being valuable. So optimizing our build system made us very busy, but it didn't actually mean they were delivering any greater value. Measurement ties in with the automation quite nicely as well, because automation allows us to have that fast feedback, giving us the information that we can then use to help steer our decisions. And of course the measurement comes in there too. So measuring the right things, being empirical and letting the stats guide us and guide our decisions. But there is a bit of a caveat here. Something we have to be aware of is that measurements can influence behavior. So once something's being measured, people can change their behavior to suit that particular measurement, so they can try and game it, let's say. So it can have a cultural impact. I think there is a quote that essentially says once you measure it, it ceases to become a true measurement. So this is something that we need to be very conscious of, and at the end of this talk we'll take a look at some KPIs and maybe have a look at some of the potential pitfalls of some of them and how they can guide the wrong behavior if they're used incorrectly. And then there's the sharing part of DevOps, so the S part of CALMS. And that's really, it talks a lot around shared experiences, so you including being inclusive and sharing your lessons, the DevOps movement has always been quite an open sourced sort of approach. It's never really been proprietary or closed source. I know a lot of people make a lot of money out of DevOps these days, but it's still a very collaborative industry and a very collaborative movement. But apart from that, I like to think of the shared part, the S in comms, as creating that shared goal, understanding your common purpose across the whole business and operations side. We mentioned earlier Gene Kim and his 3 ways of DevOps. This is taken from his blog. So he talks about the first way, which is system thinking, and that harks back to the lean IT that we were talking about. And again, he identifies dev side really being the business, and then ops side being the operational side of the business. And so he encourages us to think of the whole system. So think of systems thinking. Don't think of isolation. Don't think of just development. If you're in dev, don't just think of your world as the dev world. Don't think of the QA world as everything. If you're QA, and likewise on the operational side of the world, if you're an infrastructure person, you've got to appreciate that you're playing a part in the bigger picture, and you have to understand that bigger picture. What is the system? And then in the second part, we've got the second way, amplify the feedback loops. So let's get really good at getting things from dev to ops, and then getting measurements and metrics and feedback back to dev as quickly as possible. So if we can amplify that feedback loop and make sure that we can get that feedback really, really quickly, then we can start to make some pretty clever and smart decisions. And this is the third way. This is a culture of continual experimentation. So with all of these exceptionally fast feedback loops, we can start to take the odd risk, I suppose you could say. We can start to experiment. We can start to put some changes out there that we can maybe just A/B test. We can put out some experimental changes and say, let's see how this goes, because we've got a lot of measurement coming back. We've got the fail-safe. We've got a bit of mitigation built in. We know that if this doesn't work, then we can deploy another change out within 10 minutes. So we've got these exceptionally fast feedback loops, so we can start to experiment a little. It's that culture of continual experimentation and creative learning that allows us to explore and exploit potentially different new innovations. Potentially different new industries, and protect ourselves as well from industry disruptors and black swan events. So if something calamitous does happen to our industry or to our particular organization, we can move very, very quickly to change course. So those are the principles. Let's take a look at the practices. The DevOps practices, it's quite an interesting one, this, because a lot of these things actually predate DevOps, but they're now considered to be DevOps practices. An example is infrastructure as code. Infrastructure as code has been around for quite some time, but it's now very, very popular. So I've got a bit of, as you can probably tell, I'm not into this particularly. I'm not an infrastructure as code type person. I've not been doing this for many years, but that looks like PowerShell to, PowerShell to me. And we are standing up a VM in an Azure cloud service by the looks of things. So this is a simple concept of using what was essentially development practices within the operations world. So declarative, reusable, automated, testable scripts, source controlled, of course. So this was one of the first steps into DevOps for many of us from the infrastructure world in the olden days. So creating scripts to provision our infrastructure, let's say. And that was really backed up by the advancements in the cloud. Previously we would have done this perhaps on something like a VM farm on our VMware servers or something like that. But it's equally applicable to Azure, AWS, and all of the others. As it says there in the box, declarative, reusable, automated, testable, these are all the advantages, of course. You can also add there sort of self-documenting, It being source controlled means you can version it. Traceability. There's a great deal of advantages here. We've got some configuration as code here. This looks like some chef stuff. So what's this doing? Package Apache 2. Okay, so what we're doing, so there's a big difference here between configuration code and infrastructure as code. A lot of people use the terms interchangeably or just say infrastructure as code to mean provisioning servers and deploying applications onto them, such as, in this case, Apache by the looks of things. But we like to differentiate between the two. There could be two distinctly different steps. One is provisioning, the other one is configuring. So we call this configuration as code. And as we can see here, this looks like Chef. And we are using Chef, which is a configuration management tool, to install a package on whatever flavor of Linux, by the looks of things, to deploy Apache on there. So this again has all the advantages. It's scripted. We've got no people actually going onto these servers and fiddling around with them and potentially making mistakes, or going onto servers, configuring them and then not letting anyone know, which means that we've now got different environments with different configurations. So as long as we've got something like a configuration management tool like Chef, we can make sure that we keep all of our environments in sync. I'm also aware that Redgate have a very similar tool for databases, so that it lets you know if there's any drift between your databases. So configuration as code has been a real enabler in the DevOps world, and something that's I guess you could say really taken off. Very popular. There's plenty of tools out there that allow you to do this now, and they're just so exceptionally usable. So the cloud, again, this is something that's really ubiquitous in the DevOps world, I suppose, and actually now really driving DevOps. A lot of the great ideas are actually coming from the cloud vendors, I suppose. So as it says here, it's innovative. They are exceptionally innovative. We'll just look at the likes of Lambda from AWS recently, and all of the sort of platform as a service ideas that have been coming through. Gone are the days where it used to be demand from users that were forcing the vendors to come up with ideas. It now seems to be the other way around. We've got some of these fantastic vendors coming up with great ideas, and then we change our practices to suit these really good ideas. So we're learning from the tools, and that's fantastic. So yeah, the cloud brings high configurability, highly visible. They've got such economies of scale with AWS and Google and Azure that they tend to be cheaper as well. Highly scalable, and of course, pretty much everything's automated. So you don't have to go clicking around in UIs. There's always an automated solution to doing these things. That wasn't always the case about sort of 5-6 years ago when we were using sort of vCloud Director and that sort of thing. There were some things you still had to do manually. The Power CLI stuff wasn't quite where it needed to be, but these days it's all super automated. And again, the value of it being automated is it generally means it's scriptable, which means it's reliable and repeatable. Test-driven. So we've brought the whole concept of test driving your development to the operations world as well. So it's another thing that we've kind of borrowed from development. And here's an example of a test-driven story that I might write for myself as a lazy ops guy. I want an Ansible role that will essentially install Apache server so that I can host the best website ever. This is an example that I've got from the internet somewhere. I can't remember where, but I like the additional notes here because it says that they want the NSA to have a root account on all of the environments. So I thought that was quite topical. So we'll take a look at this story, essentially, this user story for an ops person to create an Ansible role for installing Apache server and see how it looks in our configuration code. So we can write this test in server spec, for example, and this will actually test our configuration code before we've even written the code. So if you really wanted to go down and down the TDD route and really stick to its principles, you'd write the test first, see it fail, then write the code that makes the test pass, and hey presto. Not always highly applicable in the sort of infrastructure as code or the configuration as code world, because you're talking about probably having to stand up a machine first. So if you wanted the full pipeline, then it's probably wise to write both the test and the code at the same time. But anyway, this is a good diagnostic tool and a good smoke test too. So anyway, we're using ServiceSpec here that basically checks that Apache 2 is installed. As you can see, it's largely very human readable. It also checks that Apache 2 is running, and it should be listening on port 55555, and of course that the NSA exists as a root user. Perfect. It's really highly accessible, human readable, and test driven. Perfect. Continuous delivery. Continuous delivery is a core concept, I suppose you could say, of DevOps, and of course it also predates DevOps in the sense that it was even mentioned as in one of the 12 principles of the Agile Manifesto. In fact, it says our highest priority is to satisfy the customer through early and continuous delivery of valuable software. And that was written, I'm going to take a punt at 2001 here. That was the Agile Manifesto. And so even back in those days, they were talking about continuous delivery. Quite whether it meant in their heads the same thing as what continuous delivery ended up turning out to be when Jez Humble and Dave Farley wrote the book, I'm not entirely sure. But some years later, let's jump forward about 5 years, and then this book, Continuous Delivery, came out by Jez Humble and Dave Farley, and it talks about sorry, go back one slide. Talks about the continuous delivery of code through all our different environments. So you check your code in once and deploy it out through all the different environments. We'll take a bit of a look at that in a minute. Here's a fantastic slide by some chap called Alvaro Sanchez. Thank you so much for this. Talks about microservices. Microservices versus monolithic. So there's a lot of talk in the industry at the moment about the right architecture for doing DevOps. There are a few things that a lot of the sort of fast-paced DevOps organizations that everyone's heard of, the likes of Etsy, Facebook, Netflix, and those guys, they have in common, perhaps not so much Netflix, but sort of AWS's and Google's, they have this highly microserviced architecture, so it's very, very flexible. The idea there is that essentially rather than having this tightly coupled monolithic architecture, you've got either completely decoupled parts or loosely coupled parts, which means that you can treat them separately, you can deploy them separately, you can change them at separate rates, and you're not risking the uptime or the quality of a different part of your system by changing one of your microservices. So it's a great architecture. It's really is an enabler. But as this slide really handily points out, it doesn't make it's not a miracle that's going to make all of your systems work perfectly. If your monolith, if you somehow manage to make a steaming pile of monolith from some poor use of development practices or whatever, then you're equally likely to be able to make some pretty awful steaming piles of microservices if your development practices are the root cause of the problem. Simply switching your architecture isn't going to fix that. So this slide makes that nicely apparent. So back to continuous delivery. Continuous delivery as a concept really embodies quite a lot of what DevOps is about. We talked earlier on about the automation, the feedback loops and all of that sort of stuff, and continuous delivery relies exceptionally heavily on that. So it's all about getting those feedback loops to the developers, the users, the product owners as quickly as possible from every stage of your pipeline. So from the moment you check your code in, you can run a build that will analyze the quality of your code and perhaps run your unit tests and straight away send you some detail about the quality or the success of those unit tests. If they passed, then it will automatically create a package and store that package in an artifact repository and then deploy that down this pipeline along with all of its dependent changes such as database changes and so on. So it will go to the test environment, run some integration tests perhaps or some acceptance tests, then go to another test environment, perhaps a performance test environment where it will run some performance tests, all the while giving us feedback about how those tests have gone. As you're going down the pipeline, you're therefore gaining this confidence that what you're deploying is going to deploy nice and safely, and you're not going to get called out in the middle of the night. The current best practice, of course, is to configure these, stand up these servers, these VMs, and configure them on the fly. So instead of deploying it onto a currently in use test environment, you simply provision another one and automatically run all your tests against them. So this can be entirely automated. You can check in a piece of code, 5 minutes later you've stood up an entirely new test environment in, let's say, Azure or AWS or something, and you're running your tests, your acceptance tests against them without anyone having to intervene. And so on, all the way down the pipeline until you go to production. There's a subtle difference there between continuous delivery and continuous deployment. The concept with continuous deployment is that it goes to production whether it's good enough. If it passes the test, it essentially gets deployed, whereas continuous delivery recommends that you put a manual check in there, so you could bundle up some of your changes and deploy them as part of your release cycle. So there's a manual check in there before you go live. So it's a subtle difference. Either way, the whole point in this system is to optimize the end-to-end with a high level of automation. Dave Farley came up with 8 principles of continuous delivery. I've scribbled them down here, but there's a couple of quite interesting ones on there, and he's also backed them up with these 4 practices, which we'll move on to in the next slide. But to quickly cover some of these off, I like the one that says the process for releasing and deploying software must be rapid, reliable, and repeatable, basically, across all of the environments. So you've got to use the same mechanism for deploying across all your environments. Don't deploy using one mechanism all the way through to pre-prod and then suddenly change the way you do your deployments out to the production environment. That defeats the object. Automate everything. Obviously, it relies on a high degree of automation, otherwise your feedback loops are going to be too big. Number 3 is one of my favorite ones, only because it's a bit contentious. If something's difficult or painful, do it more often. I say no, don't do it if it's painful. What he means to say here is if something's difficult or painful, make it less painful. So automate it and then do it more often. So keep everything in source control. It's surprising to see that there's a lot of places where source control isn't being used, certainly within the ops side. So that's something that these principles seek to address. Done means released, which is easier said than done. The real world and being a bit pragmatic about it doesn't necessarily mean that has to be the case. Build your quality in right from the start. This is a focus on things like your code quality, code coverage, and so on. And that everyone has responsibility for the release process. This is very much a DevOps principle as well. So there's a correlation between continuous delivery and DevOps is very apparent there. And improve continuously, which is the Kaizen of the Agile world, if anyone's into the Agile stuff. Continuous delivery's 4 practices are build the binaries only once, don't rebuild them. If they pass, they pass. If they fail, you go and fix the source and then you rebuild the binaries. Use precisely the same mechanism to deploy to every environment, as we said earlier. Smoke test your deployment, and if anything fails, stop the line. If anyone's read the Toyota Way, then they'll recognize this. It's part of the Toyota production system. So again, borrowed from the Lean IT story. got a slide here on tools. If there's anyone from a chemistry background, they'll recognize what that is. That's our periodic table of DevOps tools. And as you can see, there's a plethora. There's just bazillions out there. What are the best tools for the job? There's no right answer to that. It all depends on personal flavor, your particular environment, and so on. And I won't dwell on any particular tools here. We've all got our favorites, but suffice to say, there are tools aplenty, and there's a tool that can do what you want it to do. It's just a case of going out there, taking a look, and trialing a few, I suppose. More often than not, organizations have got too many tools. I don't think I've ever come across an organization that has said, do you know what our problem is? We haven't got enough tools. That would be a first. So DevOps Applied, how do organizations do DevOps? And this is where our background as a DevOps consultancy and engineering group comes in. We've got a lot of organizations as part of our sort of customer base. Here's a few. And one of the things that they all have in common is that the way that they do DevOps is different for all of them. There's no one-size-fits-all, and there's no silver bullet. So even though there are some principles and practices that they share in common, the actual implementation, the way that it looks and feels on the ground, is different. But there are some approaches that are fairly common. So when we talk about DevOps, one of the first things you need to do is to transition to become more DevOps if you're from a more traditional background. And this is what we recommend. First of all, establish your goals. So we went on about the shared goals aspect earlier on, and that's why this is very, very important. So understanding what your shared goals are. Then what we do is we build the platform, which is take a look at your environments, take a look at your continuous delivery platform, the way that you get your changes out into these environments, and then take a look at test automation, because what we're going to build is going to be highly reliant on high degrees of test automation. Then we assemble the team. We'll take a look at some team topologies in a second. So that's quite an interesting one. So what is in a DevOps team? What's in a delivery team or a product team? And then we take a look at process. So apply a process that's going to be sympathetic to DevOps. What kind of process do you think is going to support DevOps? I'll tell you one, it's not waterfall, because that pretty much encourages silos and handovers. We want one that's going to encourage collaboration, which is why we always recommend something along the lines of Kanban or Scrum or something like that, and an agile style of process. And then finally work together to achieve great things. Don't stop there, always collaborate. And we try and take a look at this autonomy, mastery and purpose approach of giving teams the skills, the empowerment and so on to be able to really innovate. That's something that Dan Pink talks about in his book Drive, about what motivates individuals and teams. It's a very good book. There is a temptation to try and address your culture first and try and do a big organizational cultural change. It simply doesn't work. There's many documented cases where organizational cultural change has just dragged on and on and on and been ineffectual. So please don't try and address it directly. Culture is an intangible, so trying to address it directly is always going to be a struggle. And secondly, there's probably not one culture in your organization anyway. There's many. There's subcultures. And trying to address them all or trying to destroy them all and build a new one, it's going to be too hard work. So what we recommend is to go down the sort of isolated DevOps approach, stand up a team, as we mentioned in the previous slide, do good things and get attention and try and grow that DevOps culture from within. And then scale that out, do another one, and then another one, and then another one. Don't try and do it big bang across your whole organization. It simply won't work. It's not a very agile approach anyway. So the DevOps topologies, this is how organizations organize their organizations. This is one of my favorite slides, and it talks about the sort of traditional way that we organize our organizations. In the olden days, or actually currently, a lot of organizations are organized by role. So we've got the PMO, BAs, for example, devs, QA, they all work within their own department. And that's how they're organized. Why did we do it like that? There's a number of reasons, but essentially it's because it was easy to manage. Of course, getting software across all of those silos and all those departments is bloody hard. It's not as easy as if you had an optimized team, optimized for delivering the software. So that's what we've got in the second option here. Down at the bottom, we've got a delivery team that has a BA, a DevOps coach in it, a QA, Dev, DBA, so on and so forth. All the roles necessary to be able to deliver software. So it's optimized for software delivery. We didn't come up with this idea. There's loads of organizations that are doing it. So you look at the Googles, the Amazons, the Netflixes, Facebooks of this world. They've all got different approaches to doing it, but many of them follow this delivery team, this optimized delivery team approach. We do an exercise when we're doing some consultancy that takes a look at that model at the top and see where problem areas arise, and you wouldn't be surprised to learn that most problems are with handovers, and all those handovers happen at the boundaries of all of the teams. So the more barriers you've got, the more silos you've got within your organization, the more likely you are to have trouble releasing software. I think most people now appreciate that. Here's a slide that depicts the tribes, squads, and guilds and chapters that they have at Spotify. It's a picture by Henrik Nyberg. If you're doing a presentation on DevOps and you've not got a picture by Henrik Nyberg in there, then you're doing it wrong. And this is an excellent model for how to do essentially an agile DevOps approach to organizing your teams. So if you look at that picture there and you see the squads, a squad within Spotify is essentially a cross-functional team that has all the skills in it to really get its software out the door. So you have a DBA in each one of them, if necessary, a UI guy, potentially some QA people, developers, infrastructure people, security maybe, and so on. So these organizations, these squads, really a bit like mini startups in themselves. So they've got a great deal of power and autonomy. They can even choose their own sort of tools and processes and so on. Another approach is to have this big platform team which supports all of the other delivery teams and provides a mechanism for getting all of the software out the door. So it'll be essentially the conveyor belt system, the continuous delivery system potentially that all the delivery teams just drop their software into. So think of it as a, so if you've got the right shape block to drop onto that conveyor, then it goes. If it's not the right shape, then it doesn't. So it provides almost platform as a service to all of the internal delivery teams. And that's the model that is largely followed at Google as well. Some people look at this and say that that's far more scalable by standing up as an individual platform team, but you only have to look at the likes of Spotify and Amazon who do it very differently. They have the more autonomous delivery teams with the you build it, you run it approach to realize that yeah, that is scalable too. Not many organizations are doing this at larger scale than Amazon. Here's a pretty picture that we at DevOps Guys came up with that basically talks a bit about the optimized topology for doing DevOps in one picture there. We see one of the key aspects of applying DevOps is that you've got to start to think of your product backlog or your service backlog as not just user stories for functionality or features, but about operability as well. So why not have your operability stories in your product backlog? It's an absolute must. So I absolutely insist on seeing stories about deployability, scalability, testability. These are first-class citizens, and this is what really differentiates DevOps from traditional agile approaches or even waterfall approaches. We recommend a Kanban approach to managing your day-to-day work and underpinning that with continuous delivery. And again, we see here the delivery team, which is cross-functional, has all the roles within it to be able to be in control of its own destiny. We also see down here on the bottom left-hand side a triage team. So a triage team are the guys who field the bugs and the support stuff. So the reality is in real life, a lot of us are working on systems that are already out in production, and we get constantly interrupted with incidents and escalations. And that can have an impact on our productivity. So we can either siphon off part of our team and call them the triage team and rotate the roles through that, or we just leave that as part of the team. And we accept a certain amount of interruptions going to happen, and the triage team will be the people that are dedicated to trying to make sure that they provide a certain amount of protection for us by dealing with these interruptions as best they can. So what you don't want to have are two separate teams, one that sort of creates the products and the other one that fixes the issues, because then essentially what you're creating is the bug making team and the bug fixing team, which means there's no feedback loop because the people who are making the mistakes aren't learning from them. So that's what we're trying to counter there. DevOps Solutions from DevOps guys. Our approach is to follow this model of educate, accelerate and transform. We firmly believe that DevOps coaching, the workshops and training provides that firm foundation and gets everybody on the boat and on the right page to start off with, and only then can you start to accelerate, start to look at all this engineering, automating the hell out of stuff to provide those fast feedback loops, and then slowly but surely you'll transform your organization. We said we'd focus on some KPIs right at the very end, and true to form, this is pretty much what we're going to do. Here's a slide from Gartner which talks about all sorts of KPIs. Now, as I mentioned earlier, be very wary about the ones that you choose to use because they will start to drive behavior. You don't want people just trying to gain your KPIs. So think about that. Have a nice blend have a nice blend of KPIs that focus on G metrics being empirical and other KPIs that focus on people and productivity. So yeah, don't focus too much on simply the traditional stuff like mean time to recovery and all of that sort of stuff, bugs per month and that sort of thing. Here's our standard recommended reading list. So we've got the Phoenix Project and the Goal, which are one in the same book. One was written a few years later and is more relevant to the IT industry. That's the Phoenix Project. We've got Simon Sinek's Start With Why and Daniel Pink's Drive, which are both really, really good books about motivation. Continuous Delivery by Jez Semple and Dave Farley. Great book. I'd recommend that if you've got a book club running at work, then chew your way through that over the course of a few weeks and discuss each chapter in detail. Both really good books, and some other examples of great books there as well. And that's pretty much it. Hopefully we've got some questions. We've got a couple of minutes left.
Well, we've got plenty of questions, James. Thank you very much for that. I would love to go through this list since we seem to have a few minutes. I'm going to start going way back to when you were talking about tools and start with a question about Linux and open source versus the Windows stack. And so the question is, DevOps appears to be leaning heavily towards Linux and open source. However, many of us have Microsoft products. Docker is not mature for Windows. How does that affect the implementation of DevOps for an organization?
Yeah, I'd refute that now. I mean, we work quite closely with Microsoft, so we're quite close with Microsoft, and we know that they're doing some fantastic things. They are now, what is it, the biggest contributor to open source projects in the world, or something along those lines. And you can see that trend with the way that their new applications and products are going. So sort of the Nano server and all of that, and Docker for Windows. Absolutely correct. It's not mature just yet, but it's on their pipeline. It's definitely on the radar, and that's the way that they're going. So ASP core and all of that sort of stuff is designed entirely with open source and usability in mind. Azure from Microsoft is fantastic, so feature rich. There's a container service, there's Azure container service there as well, which helps you to use Docker if you're using Linux, and obviously the newer Windows Nano too.
And just to help us calibrate, do you have people who are really for real doing this in production today?
Which part?
I mean, that sort of Docker on Windows, that really rich kind of stack on the or that rich kind of pipeline, but with the Microsoft stack.
Really, really good question. Not so much on the Windows side, because as you say, it's not as mature, but it's certainly maturing and will be there soon. But yeah, we're focusing quite a lot on containers there. I wouldn't say I see containers being the ultimate solution right now. They do fix the problem. If I was going to be writing an application or product from scratch right now, then containerizing the way I do my deployments would seem like a good idea. But there's still that whole security question that I haven't heard answered in a particularly strong way so far. With containers, I'd be very worried about how they manage secrets.
Okay.
But a few years ago, I was at one of the London DevOps Exchange meetups, or one of those London DevOps meetups, and there was a show of hands around who was using Docker, and I think there was about 100 hands went up, and how many people were using containers in production, and one hand went up.
Mm-hmm.
And there was so a very, very small minority of people who were actually using it in production. And then just before Christmas, I was at a similar meetup, and they asked exactly the same question. And the number of people now using containers in production is very, very high. So rather than just the one hand, it's pretty much everyone. So
All right.
the technology is moving.
Okay, well, not to get too hung up on tools, because I know that's easy to do. There were a few questions about roles. So, for example, you had a bunch of roles on slides, and there were people who were kind of typing in questions, when they saw things come up, like if devs are doing automated testing, why would you have a separate QA role? So maybe that's one to start with, and then go on to a different role question.
Yeah, that's a very good question. So yes, I do recommend that the developers get involved in writing the tests. So there's no reason why developers shouldn't be writing the acceptance tests, for example, but they are not test experts, and they do testers. So they will always need guidance from testers, people with testing backgrounds. Nowadays, it's very popular to see testers with exceptional programming skills too. So they can actually write the tests and the test framework and maintain the test framework themselves. So there is a real convergence of the worlds there between dev and QA. So that's certainly something that we see as a trend. Probably the biggest one that's got the biggest impact is the product owner role.
That was actually the second question, so I'm glad you brought that up. So what is that role that person plays in a DevOps team?
It's absolutely central. So in a Scrum team, for example, the product owner should be the sort of one-stop shop for most decisions in terms of what goes in and what goes out for that product. In the DevOps world, we very much see that as well. We see them being the sort of ultimate source of truth about what goes into a product and how important certain things are. But of course, in the DevOps world, a product owner needs to understand the importance of things like maintainability, deployability, testability, and all of those sort of things. So the DevOps product owner role is a little different, it's subtly different to a Scrum product owner role. I hate to use the term more operationally enlightened, but it sometimes feels that way.
I love it. And so here's a challenging this idea one. So DevOps seems to be having the effect of putting infrastructure employees out of work. And there have been articles about how to make code easier so you don't need a developer. Is there like a hidden agenda here about reducing IT costs by getting rid of IT?
No, there certainly isn't an agenda to try and get rid of people. I think there's definitely an agenda to try and stop people from hacking around in production and manually fiddling around with stuff. But in terms of trying to reduce overhead, no. What we tend to say is if we can focus our operational people and all of the people really involved in the DevOps world if we can get them to focus on the more creative sides of human work rather than doing the repeatable and boring stuff that computers are really good at, that would be the ideal world.
Okay, and I think maybe time for one last one, which is, do you know of any good resources that focus on the data warehousing side, so continuous delivery for that particular class of applications?
Well, I think you can answer that question, actually.
Data warehousing. Oh, yeah. I think, well, one of the things Dave Farley himself kind of came from a data warehousing background, did a lot of work in that, and so I think you find a lot of his techniques applicable there. But yeah, so I think, because if you were talking about the database specifically, then I think we would go into more detail in Redgate tools, but I assume you mean the whole application class. And yeah, I think you find a lot of these techniques specific to that. But again, I mean, I don't know specific resources where somebody could dive into that as a general category.
Yeah, it's an interesting sort of movement in the whole database world when we talk about DevOps and trying to sort of fit in with this loosely coupled microservice architecture and be able to iterate exceptionally quickly, and what impact does that have on traditional monolithic databases? So there's a whole other cup of tea there that's a completely another webinar altogether.
Oh, well, maybe that's an idea then for the series. Well, I think that's probably all we've got time for. So thank you so much, James. That's James Bethley, who's presented for us today. And it's been an incredibly clear introduction to the concepts. And it's been great to actually have the greatest hits from Eli Goldrat to Dan Pink by Dave Farley. And so thank you so much for providing so many jumping off points for our listeners to delve more deeply into these topics. Thank you all for joining us and for your great questions. And we will be mailing out the recording, so you'll get a notification by email, and we'll also make sure the contact details are in there for James for any questions you might have relating to this subject or to the DevOps Guys services. And again, remember, this has been a condensed version of a full-day training course, so obviously there's lots more to go into. But thank you so much, James, for a wonderful introduction today.
It's been a pleasure, and thanks for all the questions.
All right, and I think we'll sign off now, and thanks to you all. Bye-bye.